In this video, we're going to go from the clavicle all the way down to the hand. We'll talk identification, key landmarks, and articulations. Everything you need to know. Here's the full list of bones we'll be covering in this section. The clavicle, scapula, humerus, radius, ulna, carpals, metacarpals, and the hand. Let's start with the clavicle, also known as the collarbone. It's an S-shaped bone that sits horizontally at the base of the neck. It connects the sternum to the clavicle, forming the front part of the shoulder girdle. It's like a strut, holding the shoulder laterally away from the body to give your arm freedom of motion. On this slide, you can see the clavicle from above. The sternal end is on the left side of the image, and the acromial end is on the right. The sternal end is thicker and rounded because it connects to the sternum. The acromial end is flatter and wider because it connects to the acromion of the scapula. The S curve gives strength and flexibility. It's designed to flex slightly and absorb shock. Now, looking at the inferior side of the clavicle, notice how it's rounder than the superior surface. That's because this side serves as an attachment point for several ligaments. You can also spot the conoid tubercle, a small bump near the acromial end. That's an important landmark. It's on the inferior posterior side, and it helps you identify the orientation of the bone. If you ever need to tell right from left, the conoid tubercle should point downward and slightly backward. Here's how you tell a right from a left clavicle. 1, the sternal end is always medial. 2, the medial 2/3 of the bone curve anteriorly. And 3, the conoid tubercle is on the inferior posterior side near the lateral end. So if it curves forward in the middle and that bump is underneath and behind, you've got the correct orientation. Next up is the scapula, or shoulder blade. This is the flat triangular bone on the back of the thorax. On the anterior side, you can see the subscapular fossa, which is the smooth depression that faces the ribs. Notice the coracoid process, projecting forward like a little hook. That's a major muscle and ligament attachment site. The glenoid fossa is the shallow socket that will articulate with the head of the humerus to form the shoulder joint. On the posterior side, you can see the spine of the scapula running across horizontally, dividing the supraspinatus and infraspinatus fossa. At the lateral edge, that spine widens to form the acromion, which you can feel as the top of your shoulder. The superior and inferior angles mark the top and bottom corners of the bone. From above, the scapula shows both the acromion and the coracoid process, along with the supraglenoid tubercle just above the glenoid fossa. Those two tubercles, supraglenoid and infraglenoid, are attachment points for the long heads of the biceps and triceps muscles. To identify right from left scapula, the spine is always posterior. The superior angle is at the top, and the glenoid fossa faces laterally toward the humerus. So if the socket faces outward and the spine is on the back, you've got it oriented correctly. Now, let's move on to the humerus, the single bone of the upper arm. It forms two major joints, the shoulder joint with the scapula and the elbow joint with the radius and ulna. The shoulder is a synovial ball and socket, and the elbow is a synovial hinge joint. At the top of the humerus, we see the head, which is smooth and rounded. That's what fits into the glenoid fossa. Next to it are the greater and lesser tubercles, separated by the intertubercular sulcus, also called the bicipital groove. This groove houses the tendon of the long head of the biceps brachii. At the lower end of the humerus, anterior view, notice the capitulum and trochlea. These are the articular surfaces for the radius and ulna. Above them are small depressions called the coronoid fossa and the radial fossa, which accommodate parts of those forearm bones during flexion. The medial and lateral epicondyles are prominent bumps for muscle attachment. From the back, or posterior, the large depression you see is the olecranon fossa. That's where the olecranon process of the ulna fits when you straighten your arm. You can also see the medial and lateral epicondyles again from this view. To tell right from left, the head is proximal and medial, always facing toward the body. The lesser tubercle is anterior, and the olecranon fossa is posterior. So if the head faces in, the lesser tubercle faces forward, and the big fossa is on the back, you've got it positioned correctly. Next up is the radius, one of the two bones of the forearm. The radius lies on the lateral side, the thumb side. It's slightly shorter than the ulna and moves around it during pronation and supination. You can think of the radius as the rotating bone. It spins over the ulna when you turn your palm. Looking at the proximal end of the radius, you'll see the head, a smooth, round disc that spins against the capitulum of the humerus. Right below that is the radial tuberosity, the attachment site for the biceps brachii tendon. When you flex your elbow, that tuberosity is where the pull happens. On the distal anterior side of the radius, we can see three main features. The ulnar notch, where it articulates with the ulna, the styloid process of the radius, which points down toward the thumb, and the carpal surface, which is smooth for articulation with the wrist bones. Notice how this side looks polished. That's the articular surface. From the back, that distal surface is no longer smooth, it's rigid. Those ridges serve as tracks for the extensor tendons of the wrist and fingers. You can still see the styloid process extending laterally and the ulnar notch medially. To tell right from left radius, the head is always proximal. The styloid process is lateral on the thumb side, and the smooth distal surface is anterior. So if the styloid points outward and the smooth surface faces forward, you're holding it correctly. Now, let's look at the ulna, the other forearm bone. This one on the medial side, toward the pinky. It's longer and forms most of the elbow joint with the humerus. You can remember it as the stabilizer bone of the forearm. At the top of the ulna, we have several key structures. The large trochlear notch, shaped like a wrench, grips the trochlea of the humerus. The olecranon process forms the point of your elbow. Below it is the coronoid process, which fits into the humerus during flexion. On the side, the radial notch articulates with the head of the radius. And just below that, the ulnar tuberosity provides attachment for the brachialis muscle. To determine right from left ulna, the olecranon is proximal. The trochlear notch opens anteriorly, and the radial notch is lateral, facing toward the radius. So if the olecranon, that wrench-shaped notch, faces forward and the small notch faces outward, that's the correct side. Here we have the wrist and hand, anterior view of the right hand. You can see how the radius and ulna meet the carpal bones. For the digits, numbering starts with the thumb as digit 1 and goes outward to digit 5 on the pinky. Here's a real anatomical hand model. This is the anterior view of the left hand. Notice all 5 digits. Digit 2 is missing its distal phalanx on this model, but otherwise you can see every bone laid out clearly. Again, the thumb is digit 1. Naming of bones, let's name them from wrist to fingertips. At the base, we have the carpals, 8 small bones in 2 rows. Then the metacarpals, numbered 1 through 5, starting with the thumb. And finally, the phalanges, which are named by both digit and position, proximal, middle, or distal. So, for example, the index finger has a proximal, middle, and distal phalanx. But the thumb has only 2, proximal and distal. That's your radiocarpal joint, a synovial condylar type. The metacarpals and phalanges form hinge and condylar joints that let your fingers flex, extend, abduct, abduct, and adduct, adduct. All of these small bones working together give your hand incredible precision and dexterity. So let's review everything from top to bottom. We started with the clavicle, connecting the axial skeleton to the arm. Then the scapula and humerus, forming the shoulder and elbow. Next, the radius and ulna, working together for forearm rotation. And finally, the carpals, metacarpals, and phalanges, forming the wrist and hand. Each bone contributes to the structure, movement, and stability of the upper limb. Understanding these landmarks will set you up for your lab practical.